So section 6.1 was where we actually had f of x, g of x, h of x, and I asked you to do different things with those functions. Maybe f of x plus g of x, maybe f of x minus g of x, f of x times g of x. And we even did composite where you did f of x inside of g of x or g of x inside of f of x. So that was 6.1. That's a huge chunk of our quiz tomorrow. But we're also going to throw in this next section, unless you don't want me to. No, you don't? I mean, let's think about this, guys. Wouldn't you want to see this question on tomorrow's quiz? Yes. It says, find the inverse of these three coordinates. Well, how do you do that? What's the answer? You just switch them. It's just 3, 0. What else? 2 and 4. That's a 0, sorry. And negative 6 and 5. I mean, that's like free points right there. So that's why I'm throwing this section in there. It's so easy, right? So we're going to have a couple of those also on tomorrow's quiz. Of course, you have this worksheet, and if you want to verify your answers, check the back. You have your answers there. Now, check this one out. Number 7, they want you to find the inverse of each function, and then they want you to graph the function and its inverse. Okay, so they want you to find the inverse. So this would be the notation for inverse, f negative 1 of x, like that. That's a notation for inverse. So how do we find the inverse? First of all, let's get rid of the f of x. Let's replace it with the y. So you really have y equals 3/4 x. And how do we find the inverse? It's on your notes. How do you find the inverse? Switch x and y, and then what? Solve for y. That's right. Switch x and y, then solve for y. So we're going to take that y, make it an x, and we're going to take that x and make it a y. So I've switched right here. The only difference between the original and this one is I switched x and y. I took these guys and switched them. They're now in blue, just so you could see the switch. And now I need to solve for y. So I need to get y by itself on the right side of this equal sign. What do I do? You could divide by 3/4, or you could get rid of the fraction one at a time, multiplying by 4. Multiplying by 4, you have 4x equals y. I mean, 3y. Sorry, let me change that. And final step would be to divide by 3. And divide by 3. So you end up with y equals 4/3 x. Y equals 4/3 x. So, ladies and gentlemen, we have our original y equals 3/4 x, and we have our inverse y equals 4/3 x. Now, they want us to graph both the original and the inverse function. Oh yeah, by the way, using the appropriate notation, you could say that this guy is the f negative 1 power of x equals that stuff up there, right? Anyway, let's graph the first one in red, the original in red, which crosses at 0. And from that 0, you go up 3/4. 1, 2, 3, 1, 2, 3, 4. You end up right here. And you could use that pattern backwards. Down 1, 2, 3, 1, 2, 3, 4 right here. You draw your line. That's my original. My inverse will also cross at 0. But instead of going up 3/4, I'm going up 4/3. So I'm going to go up 1, 2, 3, 4, 1, 2, 3 over. And I could also go down 4/3 to extend it further. That's ugly. But my point is, if you think about the red line and the blue line, and you think about the y equals x line, the perfect diagonal through 1, 1, 2, 4, 3, 1, 1, 2, 2, 3, 3, 4, 4, it really is a reflection on the y equals x line. Does that make sense? Okay. You don't have to actually graph it with this. You could have taken the original red line, and you could have taken the coordinates like 4, 3. This one's 4, 3. And you could have found the inverse of that coordinate, which would be 3, 4, by switching x and y, and you would get the reflection from here to here. Does that make sense? 0 would still be 0, but if you picked another point, so this time they call it g of x instead of f of x. It's all the same thing. It's really just like a y. And you might as well switch it so it'll look like slope-intercept form. Y equals x plus 3. So this crosses at 3, 1, 2, 3. And from that point, you go up 1 over 1, up 1 over 1. You could use a pattern backwards to extend your line as long as you want. There's your line. Now, let's find the inverse of that red equation, of that red line, by simply switching x and y. So I want to say x equals y plus 3 instead of y equals x plus 3. I switched x and y. And now let me solve for y by subtracting 3, getting y by itself. So I'm going to end up with x minus 3 equals y. And it looks better if you put the y first. Y equals x minus 3. Now what does that mean? Well, let's graph that blue line. This blue equation is the inverse of the red equation. If you wanted to use the appropriate notation, well, it's not f, it's actually g in this case. The appropriate notation would be g negative 1 of x. That's the notation of the inverse. So the inverse is x minus 3. Y equals x minus 3. So this guy crosses at negative 3. And it goes up 1 over 1, up 1 over 1, up 1 over 1. And we end up with that line right there. Now if we were to think about the reflection line, the y equals x, after all, when you find the inverse, you switch x and y. It's kind of like saying that x is equal to y or that y is equal to x. So when you think about y equals x, that's the reflection line for inverse functions. And if you were to graph the y equals x line, it would give you that perfect diagonal. Okay, and it truly does. If I were to be able to get this whole paper, get this whole paper and fold it right on this line, this red line would completely land on this blue line. It's a reflection right over that y equals x line. Now you don't have to draw this y equals x line. I just want to talk about it, show you that it truly is a reflection. This coordinate 0, 3 gets reflected over to 3, 0, right? This coordinate 4, 1 gets reflected over to 1, 4, 1, 4 right here, right? So all the coordinates just become a reflection over the y equals x line. It's really switching x's and y's. Let's jump to something more fun. Okay, so down here it says determine if each pair of functions are inverse functions, right? Yes or no. So in order to determine if f of x and g of x are inverse functions, this is what has to happen. Two things have to happen. When you take your g of x function and plug it into your f of x function, you should get nothing else but x. Okay? And likewise, when you take your f of x function and plug it into your g of x function, you should get nothing else but x. Okay, so that's the last fact that we wrote on today's notes. So when you plug in one function into the other, everything should cancel out except for x. So it's really like doing two problems here. Let's do this guy first, where you take g of x and plug it into f of x. So we're going to take the g of x function and plug it into the f of x function. Okay, so you really have, instead of f of x being negative 4x, I'm going to put, you know what, let me write it over here on the left side. So instead of negative 4x, I'm going to put negative 4 parentheses and then plus 1. That's my f of x function. But what am I plugging into my f of x function? What am I going to plug in here? My g of x function. Does that make sense? So I'm going to plug in the 1/4 times 1 minus x. That's an ugly function. I'm plugging it in. Okay? Now, if these are inverse functions, then everything should cancel out except x. So let's actually do any math possible. Inside 1 minus x, you can't do it. But the 1/4 could be distributed to both. So when you go 1/4 times 1, that's 1/4. When you go 1/4 times negative x, that's negative 1/4 x. Now we still have the parentheses, we still have the negative 4, and we still have the plus 1 at the very end. So now we could distribute the minus 4. And if we distribute this minus 4, negative 4 times 1/4, what is that? It's just negative 1. If you put the 4 over 1, multiply top with the top, bottom with the bottom, you're going to end up with negative 4 over 4, which is just negative 1. And likewise, when you go negative 4 times negative 1/4, that becomes positive. The 1/4 and the 4 cancel out, but you have an x left over. And then when you bring down the plus 1 that was on the outside, you have 3 terms, 2 of which could be combined. The negative 1 and the positive 1 completely cancel out, and we truly are left with x, just x. So far, check, it works. Why does it work? Because that ends up being x. So far, it looks like it is an inverse function. But you have to check the other one. It has to be true for both. Not only do we just plug in g of x into f of x, but we also have to go back and plug in f of x into g of x, and it also has to give us a result of just x. So I'm going to take my f of x and plug it inside my g of x. I'm going to take my f of x and plug it inside my g of x. Okay? So my g of x function, let me put this line right here so we could separate our work. My g of x function is really 1/4 parenthesis 1 minus x, but instead of x, I want to put some big parentheses right there. Why am I putting big parentheses? Because inside this x spot, inside my g function, I need to plug in what? F of x. And what is f of x? Negative 4x plus 1. That's going to go right in here. So there it is, negative 4x plus 1. And when I work it out, I need to, in this case, distribute that minus sign. So that's going to change it to a positive 4x. That's going to change this to a negative 1. And we still have the parenthesis, the 1 out there, and the 1/4 over here. So inside the parenthesis, I still have a positive 1, a positive 4x, and a negative 1. And the 1 and the negative 1 cancel out, which means I just have a 1/4 times 4x left over. And you could put the 4 over a 1 if you want, and then multiply top with the top, bottom with the bottom. You're going to get 4 over 4 with an x up on top. And of course, the 4's cancel, which means that you just get x, and you've verified it. That's a second check right there. This one worked also because it does equal x. So what do we say about number 11? You say yes. Yes, these guys are inverse functions of each other. Let's jump to, let's say number 13. Running out of time here. Let's verify that these guys are inverse functions of each other. So in order for that to happen, you have to do f of g of x. Let me do g of x in a different color. G of x. And that should equal x. But you also need to go back and do g of f of x. Wow, that's the ugliest g I've ever. G of f of x. And that should also equal just x. Everything needs to cancel out except for x. So let's start by doing the f of g of x first. That means I'm going to plug in my g of x into my f of x. I want to take this guy and plug it right into this guy. So instead of 2x, I want to write 2 parentheses. That's going to be 2 parentheses. And what am I plugging into this x? I'm plugging in the g of x function into my f of x function. So that's going to end up being a negative 2x right in there. And could I do any math here? Yes, of course. What's 2 times negative 2x? Negative 4x. Ladies and gentlemen, is that just x? No, it's not. So right there, I could just stop. I'm done. Because I already know that f of x and g of x are not inverses. They're not inverse functions. Because if they were inverse functions, you'd end up with just x, and this is clearly not just x, it's negative 4x. So keep in mind, everything needs to cancel out except your x. If you have a number, they're not inverse functions. All right, everything needs to cancel out except x. So we don't even have to go and do g of f of x, because we already know it didn't work for one of them, so we know that they're not inverse functions.